Hey everybody, and today we're going to be looking at the equation of a circle. Um, yeah, we're going to be looking at the equation of a circle. So let's start by writing down the equation. That would be a great idea. So here we have our circle equation, and I'll talk a little about it and what these letters mean. So we have x minus h all squared plus y minus k all squared equals r squared. Now, what does this mean? We have h and k here. These are both just the coordinates. I'm going to write chord with two O's. And this is going to be the coordinate of the center of our circle. Wow. Yeah, well, x will be. It's because the h here is attached or subtracting from the x. This is the x coordinate of our circle, and of course that would mean that k is, I don't know why I wrote k a second time. That's supposed to be a y. K here is the y coordinate of our circle, the center of our circle, that is. And of course, radius is also present because we're talking about a circle. So r is our radius. R is our radius. Now, I won't be going into the derivation of the actual formula, but you can see just based off the way it's structured, it looks very similar to the Pythagorean theorem and by extension, the distance formula. And generally what this means is because it's, like that, we essentially, a circle is no more than just a set of points that are all equally distant from one center point. That's what a circle is. It's just a continuous little, I guess, ring of points that are all equidistant from a center point. Let me zoom out. Can I like move this? Oh, I did not want to do that. I don't know how to. Can I like move around? Here. Oh, I can. Okay. So we're gonna leave this off here as my this is about my second time using whiteboard, so that's why. But here we're just gonna keep this as our note, and we're gonna go into some practice problems. So yeah, like I said, it's just a extension essentially of the Pythagorean theorem, as is many things with coordinate geometry, but especially this one, as it is very heavily related. So we're gonna do some practice problems. Let's do number 1. This one's pretty easy. It states circle with center 4, 3, and radius of 14 is graphed. What is its equation? Well, this is pretty easy. The center is 4, 3. So because of that, we just want to take the x coordinate and plug it into our h, and the y coordinate plug it into our k, and the radius is 14. So we just have this here. So let's write out that equation. This comes out to be x minus 3 squared plus, oh sorry, not 3. Let me go back. Not 3, it should be 4 squared plus y minus 3 squared. There you go. It's a terrible 3. 3 squared is equal to 14 squared, which I believe is 196. 196 slash 14 squared. We're not dividing, it just means that is also equal to 14 squared. That's pretty easy. Just one quick note, we keep the sign. So because the this base sort of abstracted version is just x minus h, if we were to have a negative x coordinate for our center, it'd actually turn into a plus because the double negative becomes positive. So keep that in mind. Number 2, we have, let me write this out. This one is also pretty easy. Given x plus 7 squared plus 7 squared plus parentheses y minus 3 squared. Let me close that out first. Squared equals 144. I'm sure you could guess what we're going to do. We're going to find the center the coordinates of the center and its radius. So as I stated earlier, since the base version of this equation without any numbers plugged in is x minus h and y minus k, when it has x plus 7, that would imply that the 7 is actually a negative because the double negatives become a positive. So our center, I'll just put C for now, center is actually going to be negative 7, not just 7, and then it'll be negative 3 because the base equation is minus k. So this is just a positive 3. So that's our center, and our radius, of course, is just the square root of 144. Now we're not going to take, plus or minus. We're taking just the principal square root because we don't want to have a negative radius. So it's going to be 12. So yeah, that's number 2. Let me shift us. Where do I want to go? And here's fine. Here's fine. And we'll do number 3 over here. Number 3 is slightly more difficult, but essentially we're going to be checking if two equations given are actually circles. And we're going to do that by completing the square. So let's say we're given the equation x squared plus y squared plus 8x minus 4y plus 40, and we have this equal to 0. What we can actually do, and I'm going to shift us down because we won't need this, need a little more space. What we're going to do now is we're going to rearrange the equations so that all the x's are next to each other and all the y's are next to each other, and then we're going to complete the square on one side. So we would have x squared plus 8x plus y squared minus 4y plus 40. This is still equal to 0. So now we have x squared plus 8x and y squared minus 4y. They're all close to each other, so we're going to complete the square now. So of course, x squared plus 8x. Now 8 over 2 is 4. 4 squared is 16, so we're going to add 16. Now I'm going to put this in parentheses, and we're going to subtract 16 again, so we don't change the value of the equation. We're going to do the same thing for y squared, so I'm just going to pre-parenthesize it. Y squared minus 4y, and of course, doesn't matter, we're squaring, it's going to be positive, but we'll have 2 squared, so it'd be 4 minus 4 plus 40 equals 0. Now the reason we did this is now we can essentially factor these out because they're now perfect squares to make it look like our original equation. So let me do that real quick. This comes out to x plus 4 squared. X plus 4 squared. We still have the minus 16 out front, or out the side. This one becomes, I believe, y minus 2 squared. And so after doing that, we're going to actually add these two constants. So negative 4 plus 40 plus 36. Now we can move these constants to the front. So we add 16, subtract 36. Adding 16 to 0 is 16. Minus 36, though, we get negative 20, which is a problem. So let me just write out this equation. We get negative 20. Now this isn't super great because this would seem to imply that our radius is actually imaginary. It'd be whatever the square root of 20i is, so just root 20i, and that's not super cool because we can't exactly have imaginary or negative radii. So this is in fact not a circle, and just to confirm this at the end, I will graph it on Desmos. So we're going to do the same thing, but this time it will be a circle, and I'll show you why. This time we're going to have x squared. Let me draw a line here. X squared plus y squared minus 4x minus 2y. This equals negative 1. So once again, let me move this down. We're going to move all the x's and y's to be all next to each other. So we'll have x squared minus 4x plus y squared minus 2y. This equals -1. Now from here we can once again complete the square. So it'll be x squared minus 4x plus 4. Put some parentheses here. Subtract 4 on this side. And then we'll have parentheses y squared minus 2y plus 1 minus 1 is equals -1. Now we can just factor these into their perfect squares. We have x minus 2 squared minus 4 plus y minus 1 squared minus 1 -1. So if we add -1 to both sides, that becomes 0. Add 4, we have 4. So ultimately this equation, I screwed up already. Ultimately this simplifies down into x squared plus parentheses y minus 1 squared equals 4. So now we can see that our radius is in fact positive. If we were to take its square root, it would be positive, so it can in fact be a circle.